Hello everyone. Today I'm going to explain about the string instructions in 8086. Okay. String related instructions in 8086. So what is meant by the string? String is a group of bytes, a string byte. It is called as a group of bytes. Okay. And in the 8086 microprocessor, all these string instructions are executed between the data segment. Okay, so data segment and extra segment. Already there are four segments: data segment, code segment, extra segment, stack segment. So all string related instructions are executed between the data segment and extra segment. And for the string related instructions, the data segment effective address, okay, the effective address for data segment is available in is available in source index register, and the effective address for extra segment is available in destination index register. Now, what are the string related instructions in 8086? Okay, so string byte, move string word, load load string byte, load string byte. Okay, store string byte, store string word, compare string byte, compare string word. Okay, so now let us discuss one by one. First one is the move string byte. Okay, please listen carefully. Here, for example, this is these are all the segments. Already I told you. Now, this is data segment, code segment, stack segment, extra segment, and each segment size is 64 kilobytes, already mentioned in the previous videos. And this is the segment base, and these are all the different memory locations. These are all different memory locations in data segment. These are all different memory locations in data segment. Okay, and extra segment, this is the extra segment base, and this is extra segment memory locations. Okay, now suppose if we take a group of byte, that is string byte. Okay, so for example, in this 27, 38, 41, 25, 42. Okay, a group of bytes, 5 bytes. Okay, so this is the segment base available in data segment register, and offset address is available in the source index register. Similarly, this is the segment base available in available in extra segment register, and destination index register. Offset address is available in the destination index register. Suppose if I am giving the move string byte, so move string byte means, so this string byte, okay, this string byte is copied from data segment to extra segment based on the in which direction, that is based on the direction flag. Already we have discussed about the direction flag in the previous videos. Direction flag, okay. So if direction flag, if direction flag is if direction flag is equal to 1, then downward direction, in the downward direction the data moves, the data copied the data copied in downward direction, downward direction, okay, downward direction. What does it mean? What does it means, so suppose this is direction flag is equal to 1, then the data copied in downward direction. That means here starting the effective address, the effective address is here, okay. This is the effective address source index register, and destination index register also, it shows the value top value. Destination index register is also showing the top value, that is destination index. Now when we are giving the move string byte, then what happens? First this 27, that means from the data segment register, how the physical address is calculated, how the physical address is calculated. So physical address is equal to segment base available in data segment register into 10 plus effective address, okay. Effective address is available in the source index, okay. So that means data segment register star 10 plus source index register contents. So with this physical address, this memory location is identified, and when we are giving the move string byte instruction, this 27 is copied, this 27 is copied, this 27 is copied into present destination index is showing this memory location. So this is 27 copied here. Okay, so because of the direction flag is equal to 1, so now the source index register contains effective address is decremented by 1, and destination index is also decremented by 1. Now this memory location is identified. Second memory location is identified. Now this 37 is automatically copied into the next memory location. Okay, the 37 is copied into the next memory location. Okay, next 38, sorry, 38. Okay, next one is the again the source index register is decremented by 1 and destination index is decremented by 1. Now in this data segment this memory location is identified, and extra segment this memory location is third memory location is identified. Now this 41 is copied into the next memory location. Here 41 is copied. Okay, so with this single instruction, all the bytes are copied from data segment to extra segment based on the direction flag. If the direction flag is equal to 1, then what happens? That the data is copied from downward direction, in the downward direction. That means topmost memory location is copied first, and then source index register contents are decremented by 1, and destination index contents are decremented by 1. Now the second memory location is identified here. Here also next memory location is identified. Now the 38 is copied. Similarly, again source index register is decremented by 1 automatically. Here destination index is also decremented by 1 automatically. Okay, destination index register is decremented by 1 automatically. Then the third byte is transferred. So likewise, all the string bytes, likewise, all the string bytes are transferred from data segment to extra segment. Okay, so here because of this is the byte, string byte. Okay, so because of this is the byte, so the source index one by one memory location. Okay, so source index is decremented by 1. Here, destination index is decremented by 1. Suppose if we give the move string word, the same for the same set of data, if we are giving the move string word, so word means what? Word means 16-bit. 16-bit data. 16-bit data means it is two memory locations. 16-bit data means two memory locations. That means at a time, two memory locations data. At a time, two memory locations data is transferred. Okay, so source index register is decremented by 2. Destination index register is decremented by 2. So at a time, 27, 38 are copied. That means lower byte and higher byte is copied here. Similarly, again, the source index register is decremented by 2. Similarly, destination index is also decremented by 2. Next two bytes, lower byte and upper byte are copied from data segment to extra segment. Okay, so here move string byte means the data is copied from data segment to extra segment based on the direction flag. Okay, okay. Suppose if the direction flag is equal to, suppose if it is equal to 0 now. Okay, then what happens? What happens means 0 means the data is copied in the upward direction. The data is copied in the upward direction. Okay, so that means first the source index is shows here, the destination index is shows this position, and the lower byte, first the starting byte is copied into this. Now the source index is incremented by 1. Now here incremented by 1. Okay, and here also destination is incremented by 1. Now the second byte is copied here. So that means first 42, 25, 41, 38, 27. That means the data is copied in this direction, upward direction. Previously, when the direction flag is equal to 1, the data is copied in the downward direction. That means first 27, next 38, 41, 25, 42, like this. That is the difference between direction flag is equal to 0 or direction flag is equal to 1. Based on this direction flags, the source index register contents are either incremented or decremented. If it is a string byte instruction, the source index and destination index contents are incremented by 1. If it is a string word instruction, the source index and destination index contents are either incremented or decremented by 2. Okay. Next, load string byte. Similarly, load string word. Okay, load string byte and a load string word. Load string word means what? Here, this is used to, this is used to store the, to store the, sorry, not store, load. Load the accumulator contents. Okay, accumulator contents into the load the accumulator with the contents in the data segment. contents in the data segment. That is data segment string byte available. This is string byte. String byte available in the data segment. String byte available in the data segment is copied into the accumulator. Okay. Similarly, load string word. Load string word means this is used to load the accumulator with the contents in the data segment. That is, data segment is copied into the accumulator, but here it is only AL or AH. This is AX. Okay, this is AX. Okay, so that means load string word. That means suppose this is the data segment. Load means load the accumulator with the contents of data segment. Okay, so now this data available in this data segment is copied into the accumulator. Okay, if it is a string byte, only one by one. Okay, string word means AX register. String byte means either AL or AH. String word means AX. Okay, similarly, store string byte, store string word, store string byte and store string word. So this is used to store the accumulator contents into extra segment. That means this is the extra segment. Okay, this is extra segment. Now accumulator contents are stored. Accumulator contents are stored into the extra segment. Load means load the accumulator from the contents of data segment. Store means store the accumulator contents into the extra segment. That is the difference. Okay, but here, however, in order to identify the memory location, segment base is required, effective address is required. But for all the string or related instructions for the data segment, the effective address is available in the source index. For the extra segment, the effective address is available in the destination index in order to identify the memory location. Okay. Similarly, next one is the compare string byte, compare string byte, compare string word, compare string byte, compare string word. Okay, same as set of this. Okay, for example, this is the total memory segmentation and data segment. Here, extra segment. Okay, extra segment, data segment. These are all the set of memory locations. These are all the memory locations. Similarly, extra segment memory locations. Okay, extra segment memory locations. And as I already told you, the segment base is available in data segment register, and effective address is available in the source index. Here, segment base is available in the extra segment register. Effective address is available in destination index register. Okay, and these are all the suppose bytes. Available in the data segment. Okay, and here the certain bytes available in the extra segment. Okay, now this is one group of bytes. It is one string. And this is a group of bytes. That is one string. It is one string byte. Okay, now compare string byte. Compare string byte means the data segment string byte is compared with the extra segment. Already we know that compare instruction. Compare instructions already we discussed in the arithmetical instructions. Okay, so this microprocessor performs the string byte comparison between the data segment and the extra segment. Byte means only single. This byte is compared with this byte position. This byte available in this memory location is compared with this byte in this memory location. Okay, again same the direction flag. Again same the direction flag is equal to 1. If the direction flag is equal to 1, comparison takes place in the downward direction. Comparison takes place in the downward direction. Okay, that means first this byte is identified and this byte is identified and both are compared. Again, the source index is decremented by 1. Here the destination index is decremented by 1. And now the second memory location is identified. Second memory location is identified. Now this byte is compared with this byte. Again, source index is automatically decremented by 1. The destination index contents are automatically decremented by 1. This memory location is identified and this memory location is identified. Now this byte, third byte is compared with this third byte. Okay, so that is the compare string byte. Similarly, compare string word. Compare string word means at a time two memory locations are identified. Okay, at a time, because string word means 16-bit data. 16-bit means two memory locations are required. Okay, so at a time two memory locations. Two memory locations. Two memory locations means first SI shows this one and DI shows this one. After that, SI is decremented by 2. Destination index is decremented by 2. Next, two memory locations are identified and within this 16-bit number is compared with this 16-bit number. Okay, so compare string byte and compare string word. Okay, so here the string related instructions in 8086, the string means it is a group of bytes. Okay, and all string related instructions are executed between the data segment and extra segment. For the effective address for the data segment is available in source index register, and effective address of a data extra segment is available in the destination index register. And what are the different string related instructions? Move string byte, move string word, load string byte, load string word, store string byte, store string word, compare string byte, compare string word. Okay, so move means data segment to extra segment. Load means data segment to accumulator. Store means accumulator to extra segment. Compare string byte means the contents in the string byte available in the data segment is compared with the string byte available in the extra segment. Okay, that is string instructions in 8086. Thank you.